So I know I've skipped about 9 pages of text here. This is the summary of vector member functions. This is on page 446. Now, just to draw our attention at a couple of things here before we get into the table. We do have to include the vector standard template library when we want to use a vector. So even though we did not have to include array any longer, which remember we did in older versions of C++, here for vector, we do have to include vector all the way at the top of our repels. You will see that in the code sample that follows. Next is, remember, in chapter 6, you were creating your own function. So you had those small single-purpose blocks of code that, performed a task, right? These, it is table 7-4. The dyslexia today is real. It is table 7-4. Our member functions for vectors. So when we are using these, what we are really doing is, and this will be obscured to you, but I do want to mention how this is all working. So when we make a call to any one of these member functions, what we're really doing is we are asking C++ to go up the chain. We are asking C++ to go to that library. In this case, it's vector. And when we use any one of these member functions, we are saying this is a call to a function that exists out in that library. So when we were doing this in chapter 6, what we were doing was, can I call it hyper local function calls? Everything resided in our main.cpp, and that's perfectly okay for where we are in our development. But it's, can I call it entirely probable? It is 100% probable that you will use some of these and other member functions that belong to other members of the standard template library. And again, I know that I have become a shill for C++ 277. That is not lost on me, but we reside here with these STLs in 277. So much of this is a down payment on what you would see next semester or otherwise in your academic career. So let's just take a look here at some of these member functions. The first one you can see here is at. So at, and then inside the parens, that's a call to, or we're passing the element number. So you can see that here in the example. So we are going to assign our variable, in this case it is x, the value of our vector at sub 5. So that is a call to our at element. Next we have clear. So vect in this table is going to be the name of our vector. So what vect.clear is going to do is remove all of the elements from vect. So it does not remove just their values. It actually goes through and removes their element numbers. So this will be an empty vector, which is fine, but it's something that you should be aware of. Next is a test for empty. So if vect.empty, this will return true if our vector is empty. So from our previous example, if we cleared our vector, now it would be empty. Why is that important? If you think about data, if you think about reading in from a file somewhere, a .txt, a CSV, a comma-separated value file, you're not assured that whatever process it was that was going to do that work is going to have run before this line, the if empty. So what we're able to do here is test and see whether or not our vector has indeed gone through and been populated by data. If not, what we can do is recover from that and make sure that we're running, we can recall to whatever processes it was that we're supposed to fill that vector with data. So empty is one of our member functions. Pop back. Pushback and pop back are where we're going to live here with vectors. Just so you're aware, we're going to see these. I feel like I've said this, and I know I will again, but we'll see these in the vector example here shortly. So pop back, if you think of a vector like a stack, the stack of plates at like a buffet, for example. So that is what is known as first in, last out. You start pushing plates down, blump, 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 one on top of another. So if there are 100 plates in that stack, plate number 0 is the last one to leave, right? Because plate number 99 goes first, 98 goes second, 97 goes next. I'm going to be hungry. Not 3 plates hungry, but hungry none the less. So what pop back does is it removes that last element from the stack. So what we're doing is we're popping a plate off of our stack so that we can go through the buffet. Pushback takes that plate and it adds it to the back end of that stack. So if I have 100 plates in my stack and I push back another one, I will add my 101st plate. If I pop back, I will remove my 101st plate. You'll notice here with the vector, what we're doing is we are working with its outer bounds, the last element in our vector. So even though we do have some of these member functions where we can replace the values of our not last element, we cannot simply go through and essentially destroy them, right? So the way the vector works is from the back end. It's most immediately previous element, so the last one. So pop back removes that element. Pushback adds a new element to the back of my vector. What resize will do is it will add as many. So you'll see that there are 2 arguments there in the resize. There's elements and value. So the elements is how many elements that we are going to add to the back end of our vector. The value is what we are going to give those new elements as an initial value. 0, 1, -1, whatever it is that you want to give it. So that way you are guaranteed to be working with initialized values there. The very last one here, I will tell you, this one is strictly a down payment for next semester, is swap. What we are able to do is take the values in one array, and the values in one vector, my mistake, the values in one vector and the values in a second vector, and take and swap the values from 2 into 1. There's good reason to want to be able to do that. We'll talk about that from a data perspective, in 277. This is, as far as I'm concerned, a bridge too far for 276, but it's one of the places that we pick up with in 277. So those are some of the member functions that we will use. At will return to us the value of an element, and we can specify that element with at. Clears, I hate to reuse that word, I just can't think of a better one. It removes all of the elements of an array, or a vector. So what we will have is an empty vector. Empty will double check to make sure that our vector is not empty, which if we have just used clear, it will be. We will live, for the most part, in push and pop, push back and pop back. What we will be doing is with a stack of data. We will either be removing the last element with the pop back, or we will be adding a new last element with the pushback. And we will see those in the code samples immediately following this.